So this is the next topic. We have seen stresses in screw threads. Now stresses due to external forces on this. Here first the tensile stress, which we have seen. The bolt, stud and screw usually carry a load in the direction of the bolt axis. So due to this tensile loads are there. So DC is the core diameter sigma t. So based on that, external load applied is equal to P is equal to pi over 4 DC square into sigma t. Yes, just remember the same technique which we have used in the knuckle joint and quarter joint, where DC is what? Square root of 4p upon pi into sigma t. Based on this, you can find out the core diameter also. And table we have already seen in the previous video. You can see the previous video for the table. So this is how we can get the core diameter. So you can note down that if the external load is taken up by a number of bolts, then P is equal to pi over 4 DC square into sigma t into n, and DC is nothing but 0.84 times the small d. Now the shear stress which is induced in the bolt, that is sometimes the bolts are used to prevent the relative movement of two or more parts. So and in case of flange coupling, then the shear stress is induced in the bolt. So the shear stress should be avoided as far as possible. Just remember this part, that we need to avoid it. Okay, and it should be noted that when the bolts are subjected to direct shearing, they should be located in such a way that shear loads come upon by the body, that is the shank. Just see this equation. This is how we can do this. PS is equal to pi by 4 d square tau into n. So here we can see that. First take a highlighter here. So PS, it is equal to pi by 4 d square and tau into n. PS is the shear load, pi by 4 d square is the area, tau is the shear stress, and is the number of threads, number of bolts, sorry. So d here we can get it, that is the major diameter we can get here on this. I have already shown that we have to arrange shearing load in such a way that it should act on the body. That's why small d, that is the major diameter. So combined tension and shear loss, because we know that practically it is not possible that only one type of load is acting on the bolt or any component. A combined loading system is there. So for combined loading system, tension and shear load are acting on it. So when the bolt is subject to both tension and shear load, as in case of coupling bolts or bearing, and the diameter of the shank of the bolt is obtained from the shear load and that of threaded part from the tensile load. So this is how, with the help of two theories of failure, the maximum shear stress theory and principal stress theory. Principal shear stress theory help us to find out the shank of the bolt. Okay, this help to find out the shank of the bolt, and the threaded part is find out with the help of tensile load, that is with the help of principal tensile stresses. So this help in finding this. To based on this two, we get a major diameter, nominal diameter, major diameter, and the minor diameter for a bolt. So this is how it is done.